Welcome to This is Modern Architecture. My name is Raul, and today we have Marc from Databricks. Marc, why don't you tell us a little bit about Databricks and what do you guys do?
Sure. Databricks is a unified analytics engine powered by Apache Spark, where data scientists can do machine learning, streaming analytics to power their big data and analytics applications.
Awesome. So what do you have for us today?
Yeah. So today I brought you an architecture that powers a recommendation engine for Raul.
Oh, that's really cool. So can you walk us a little bit through what we have here on the flow? I see Snowflake over here. Is that where we want to start?
Yeah, absolutely. So Raul is a fashion retailer that specializes in flash sales. So in the Snowflake database, they contain customer data. It has the product data. And it also contains web data. They're going to use that data to develop the recommendation engine on Databricks. So their first activity is to pump the data to Databricks.
So is this running? Does this run on the customer's account, or is this something that Databricks manages for the customer?
Yeah, that's a very, very good question. So there's a number of ways that the architecture is set up, but for the most part, there's a control plane that lives in an AWS account for Databricks, and the data and compute plane lives in the customer's account. That way we can adhere to security best practices. Okay,
so the customer launches the EC2 instance on their account.
Yeah, exactly.
Okay, so talk to us a little bit of how Raul is using Databricks here. I see some text in here.
Sure. So Raul, since they do flash sales, they have changing inventory every day. So first they're going to have to run this machine learning pipeline every day in order to supply the recommendations for their customers. It starts off by doing some feature engineering. They're going to take their customer data, their category data for their products, and create some hierarchical grouping. And once they have that, they'll be able to do the model creation phase. Because this is a recommendation engine and they're using collaborative filtering, they have to do some large matrix transformations, which increases the size of the data by factors. And because so, they need to scale out their compute on EC2. They oftentimes go from 8 nodes to 20 nodes, depending on the size of the data and the amount of inventory that they're retraining.
Oh, that's a great metric on scale. How does the reliability piece of this architecture work out? Like, what happens if a node falls from the EC2 size?
Yeah, that's a good question. So one of the reasons customers go with Databricks is that's a platform as a service. So they get to take advantage of years of optimizations and stability improvements to the Databricks node driver. So that way they don't have to worry about analysts submitting commands that might crash their cluster. We take care of those guardrails for them.
What are some of those guardrails? Like, do you guys like relaunch other instances? Are you keeping stage of the data somewhere?
Yeah, absolutely. So maybe if a job or a worker or a data scientist executes a command that might cause an out-of-memory error, these types of stability improvements are put inside of Databricks' cluster manager, so it can recognize that this command might throw an error and stop that command from running, essentially.
Okay. And once you start transforming all the data in Databricks, what happens? What's the flow? How do we get all the way to the end user?
Yeah, good question. So what we're going to do is we're going to convert the data inside of Databricks to a JSON format and load that into S3, because that's the format that we wanted in for DynamoDB.
Okay.
When the data lands here, we actually have a Lambda monitoring the data landing here in S3, and it's going to kick off a batch job, an AWS processing batch job. And what that's going to do is that's going to ingest the data. It's going to auto-configure the DynamoDB write, and then it's going to load the data by row into DynamoDB right here.
So you're changing so what batch is doing is rechanging the configuration settings on writing throttling for DynamoDB in order to handle the load.
Yeah, absolutely, because the load is changing depending on the type of inventory and the amount of customers. It's changing every day, and so we want to be able to take advantage of that with DynamoDB.
So why DynamoDB and not any other like database like RDS or Aurora?
Sure, that was a very important question to Raul as they scoped out this architecture. It was very important to them to return the requests to the users in sub 40 milliseconds. And as they did their analysis, it came back with DynamoDB being the perfect fit for that type of interaction.
Right, and how, like, what is API Gateway's function here?
Sure, so when the end user interacts with the web, it's going to go through the AWS API Gateway, and they'll use their customer ID in order to look up their recommendations for them. It'll be a unique set of recommendations. And DynamoDB will return the request and send that out to the end user
This is really interesting. What is the next step for this architecture? Are you guys looking like for accelerating with Dynamo Accelerator or DAX?
Yeah, of course. Fortifying this solution with performance and stability is of top of mind because they're seeing such good improvements on their sales and their customer retention with this recommendation engine. What also is top of mind is taking more advantage of this data sitting here in Snowflake, enhancing this with new, enhancing the recommendation engine itself, or adding in new initiatives and big data and analytic projects.
Awesome. Marc, thank you for sharing all this today and sharing all this information today.
Yeah, thank you.
Thank you for watching. This is My Architecture.